Students, welcome to my YouTube channel. In this video lecture, we are going to look at some important questions from sample paper number 5, the 4th edition of RK BALI Navigation book. So let's begin with question number 77. What is the appropriate angular coverage of reliable navigation information for a 3-degree ILS glide path, okay, out to a distance of 10 nautical miles? So look at here, look at this picture. We have glide slope vertical range and the limits of a glide slope horizontal range. So horizontally, the glide slope extends to up to a distance of 10 nautical miles, 8 degree either side of the extended runway center line. Okay, so 10 nautical miles out, 8 degree either side of the extended runway center line. Now glide slope vertical coverage. Over here, this line is your 3 degree standard 3 degree standard glide slope. Okay, standard 3 degree glide slope. Now the lower limit of this glide slope will be 0.45 theta. So your aircraft, there are three possibilities: your aircraft following the glide slope correctly, your aircraft flying above the glide slope, your aircraft flying below the glide slope. Okay, so if it's flying below the glide slope, the maximum limit it can go to is 0.45 into theta. So for a 3 degree glide slope, the lower limit will be equal to, lower limit is 0.45 multiplied by theta. So 0.45 multiplied by 3 degree. Okay. So 0.45 into 3 is 1.35. So you can go up to a maximum limit of 1.35 degree below the standard 3 degree glide slope. Upper limit. Now the maximum upper limit is, maximum limit above the glide slope is 1.75 multiplied by theta. 1.75 multiplied by theta. So 1.75 multiplied by theta is 1.75 into 3. So that is equal to 5.25 degrees. So the maximum upper limit you can go to is 5.25 degree. Okay, 5.25 degree from the surface, and the lower limit is 1.35 degree above the surface. You cannot go below that angular coverage. So the correct answer here is 3 degree above and below the glide path, 10 degree each side of the localizer center line. That's wrong. It's 8 degree each side of the localizer center line. 1.35 degree above the horizontal. 5.25 degree above the horizontal, yes. 8 degree each side of the localizer center line, yes. 0.45 degree above the horizontal to 1.75 degree above the glide path, and 8 degree each side of the localizer center line. That's wrong. So option Bravo is the right answer. Option Bravo is the right answer. Okay. So whatever angular measurement they give in the question, multiply that angle with this 0.45 theta, 1.75 theta. Next. An aircraft is on radial 120 with a magnetic heading of 300. OBS reads 330. The indications on the CDI are what? So there is a VOR station, so let's draw it. This is the north datum. Okay, so this is radial 120. This is radial, reciprocal radial 120 plus 180, 300. The aircraft is flying on radial 120 with a heading of 300. That means aircraft is flying radial 120 inbound. Radial 120 inbound. Okay. It is flying radial 120 inbound towards the VOR station. Now, there are first possibility. With this picture, your OBS should read 300. You will get two indication and the CDI needle will remain in the center if you are positioned correctly on the center line of this radial 120 inbound. Now if you change your OBS setting to a new reading, let's say in the question it's 330. So let's make it 330 here. So now OBS reads 330. So 330 radial is to the right of radial 300. Radial 330. Reciprocal of 330 is radial 150. Correct? Now, initially you were going towards the VOR station, uh, flying radial 120 inbound. Correct? Overhead VOR station, you will transition onto the next radial 300 outbound. Now, when you change the OBS setting from 300 to a new setting of 330, that means you want to transition from this particular radial onto this new radial 330. Now, to effect that transition, you will have to change your radial that you are flying inbound towards the VOR. So, you will have to turn your aircraft away from this radial 120 and bring it onto radial 150. After coming on the radial 150, you are going to fly that radial 150 towards the VOR station. You will overfly that station and then automatically transition onto the next radial 330 and fly that radial outbound from the VOR station. Correct? So, what you are going to do is now going inbound, this is your left hand side, this is your right hand side. So, you will be required to make a left hand turn, intercept radial 150 inbound, intercept radial 150 and then fly that radial 150 inbound. Okay, fly that radial 150 inbound. So, okay, so you are going to fly radial 150 inbound. So you will continue getting a two indication, and what will be the CDI indication? The CDI will tell you to fly left hand side, So the CDI needle will go to the left hand side like this. Okay, telling you fly left. So left with 2 showing, right with 2 showing, right with from showing. So option alpha is the correct answer. Heading 280, VOR radial 090. What bearing should be selected on the OBS in order to centralize the VOR deviation needle with a 2 indication? With a 2 indication. So magnetic heading is 280 and VOR radial is 090. So now heading is irrelevant to your VOR operations, your OBS selection. So let's draw the VOR station. Okay, and this is your north datum. We have radial 090. We have radial 270. Now your aircraft is on radial 090 but with a heading of 280, something like this. Its position on radial 090 but heading is 280. Now heading is irrelevant to your VOR operations. Now we want to find an OBS selection that will give us a 2 indication. So there are 2 possible OBS selections right now. The first one, since you are on radial 090, you can select that OBS setting, and when you select that 090 setting, you will automatically get from indication and the CDI needle will remain in the center provided you are situated on the center of this radial. The second possibility is being in spite of being on radial 090, you can select an OBS reading of 270, implying you are flying a radial 090 inbound towards the VOR. You overfly this VOR and then transition onto radial 270 and then fly away from the VOR. So when you are on radial 090 and you select 270 in your OBS, you automatically get 2 indication and the CDI needle remains in the center. When you overfly this VOR station and transition onto a new radial 270, so automatically this 2 will become from, because that time you will be flying away from this VOR station. So this is the normal sensing of the OBS CDI. So now in order to get a 2 indication, you will be required to select 270 in your OBS setting. Aircraft carrying out an ILS approach is receiving more of 90 Hz signal than 150 Hz modulation signal uh, from both localizer and glide path. The ILS indication will show what? Now let's look at the localizer here. So this is the diagram for localizer. This is the runway. Okay, and you have two radiating patterns, 190 Hz to the left hand side, 150 Hz to the right hand side. Now when you are flying right in the center of these two radiating patterns, in the overlapping region of these two radiating patterns, your that means you are flying along the extended center line of the runway. Okay, so your OBS selector or CDI needle, in that case your CDI needle with respect to localizer will remain in the center. It will remain right in the center. If you fly along the overlapping region of 90 Hz and 150 Hz modulating signals. Now, if your aircraft, let's say, deviates to the left hand side, left of the extended runway center line, so when it deviates to the left hand side, it will receive more of 90 Hz signal and less of 150 Hz signal. When that happens, your CDI indication will give you a solution. It will give you an advisory, a maneuver that you must perform in order to come back to your extended runway center line and then follow or track that extended runway center line towards the runway. So if you go to the left hand side where you receive 90 Hz signal, your CDI indication will give you a right hand indication, meaning your extended runway center line is to the right hand side. So you have to turn right to intercept that and then fly along that track. Correct? So if you are receiving more of 90 Hz signal, in case of localizer, you are going to get a right hand indication for localizer. Now glide slope. Glide slope, you have 90 Hz signal above the 3-degree glide path, 150 Hz signal below the 3-degree glide path. Now you are going to fly in the overlapping region of these two radiating signals. The overlapping regions between these two radiating signals will be this one. Okay, this will be your 3-degree glide slope. So you are going to fly the 3-degree glide slope. Now, if you happen to deviate from the 3-degree glide slope and you are, let's say, above the glide slope, when you are above the glide slope, what will happen when you are above the glide slope somewhere here? You will receive more of 90 Hz signal and less of 150 Hz signal. When you are correctly established on the glide slope, you receive both the signals in equal magnitude. But when you deviate above the glide slope, you receive more 90 Hz, less 150 Hz. So what is the solution to that? You will be told by the CDI indicator to fly downwards, or one dot down, 2 dots down, whatever. So if you have deviated upwards, the solution is to go downwards in order to intercept this 3-degree glide path and then fly that glide path to the touchdown of the runway. So the glide slope will move. The glide slope will move down like this. Okay, telling you to fly down because that's where your 3-degree glide slope is located. So you will have to remember the radiating patterns of both the transmitters. For localizer, it's 90 Hz on the left hand side, 150 Hz on the right hand side. For glide slope, it's 90 Hz above the 3-degree glide slope, 150 Hz below the 3-degree glide slope. Okay, so fly left, no, fly right, yes, and fly down, yes. So option Bravo is the correct answer. Okay, so this is how you do this question. This concludes our lecture. I hope you have understood these 4 questions that I have solved in this video lecture. The VOR, the ILS, very important ones. I have also solved all VOR questions from Oxford, Keith Williams and RK Bali and already uploaded them to my YouTube channel. You can find them in the separate playlist that I have made for all of them. Along with that, I have also solved questions of ADF, DME, radars, airborne weather radar, ground radar, etc. So do explore my channel. You will find those video lectures ready for you. Best of luck. Share this channel with your friends. Subscribe if you haven't yet. And hit the like button if you have liked this video lecture. I'll see you in the next video lecture in which I will solve the remaining sums.